What is vector notation? Well, before we do that, what is a vector? So a vector is a quantity with magnitude and direction. At the bottom, you see 4 different examples of how we can write the same vector. So all 4 of these representations represent the same vector. The idea of what magnitude is it is pretty much the same thing as size. So the first way of representing a vector is with a directed line segment. Directed meaning that it goes from one place to another, not that it's just there. So this is the initial point, and then there's an arrow pointing at the terminal point. So initial means start, terminal means end. So it's going from 3, 5 up and to the right to 5 plus square root of 3, 7. We can say that 4 is the magnitude, and the direction we would say is 30 degrees above the horizontal. So it's worth pointing out that a vector itself doesn't have endpoints. If I moved this to a different place on a coordinate plane, as long as it still had the same magnitude and direction, we'd consider it the same vector. So, for example, if I went from 0, 0, well, this goes right 2 plus the square root of 3, and up 2. So this vector, if it has the same magnitude, it has the same direction, so we would consider it the same vector. So directed line segment is the first way to represent it. Component form. Well, components are the different pieces of a vector if you're adding them up. So if this is our vector, the 2 components, typically we will look at the x component, which is in the positive or negative x direction, and the y component. So this is x component, and this is y component. It works almost the same way as coordinates, but it is not identical. It represents how far something is changing in the x direction and how far something is changed in the y direction. Exact same idea, except with a matrix instead of the previous one had angle brackets. These are not supposed to be less than or greater than signs. They're just always done with angle brackets instead of parentheses. A matrix notation, you know what a matrix looks like. It's always this type of matrix where it just has a single column. So one column, and the first one is the x, and the second one represents the change in y. So all of these are different notations, and the last one is unit vector notation. We also could call this a linear combination of unit vectors, just like we would say 2x plus 3y is a linear combination of variables because this is linear, this is linear. Overall, it's linear. This is a linear combination of unit vectors. Well, I hat and j hat are unit vectors. So I'm pronouncing that I hat and j hat. You don't have to pronounce it that same way, but that's the way I'm used to pronouncing them. So essentially what this is saying is this is the x component, this is the y component. It's like saying that we have a unit vector, so a vector whose magnitude is 1, and it's being multiplied by this 2 plus square root of 3 to become however long it needs to be. And then the unit vector of j is in the y direction. It's being multiplied by 2 to determine what we need to go in the y component. And then those get added up to become the overall vector. So 4 different ways of representing them. Directed line segment, component form, matrix form, and a combination of unit vectors. It is worth pointing out that there are multiple ways to type these. I don't use all of these with the same frequency. Bold V is an option, but the one that I prefer for describing a vector is a V with half an arrow over it. That's what I'm used to, but a bold V is just as good to describe vector V. Either one of these is fine. Unit vector I. Sometimes people just use the exact same notation as for a vector, and they would tell you out loud, oh, this is a unit vector, or they would write, this is a unit vector. So you could write it like that, or that, with half an arrow over it. The last way I already showed you was with a hat on top of it. This shows that it is definitely a unit vector, meaning that it has magnitude. Magnitude 1. And the magnitude of vector V, well, we will take whichever way you prefer writing V and put double parallel bars around it. You can think of it like absolute value. Now, there are some people, and I really don't like this notation, who will use single absolute value bars. And I've tried to include that sometimes because you'll see it, but that also sometimes means the magnitude of vector V. The standard unit vectors, the unit vectors are ones whose magnitudes are 1, are typically I hat is described as 1, 0, so going 1 unit to the right and 0 units up, and j hat is 1 unit up and 0 units to the right. So those are our standard unit vectors. We could use different unit vectors. We're not going to for now. Thanks.